right. Hi. Welcome, everybody. Welcome to today's live stream. I hope you all had a good day or a good start of the day. Today we're going to talk about GenAI again. What I messed up in my last project. I found this out over the weekend. I couldn't let it go, so I was looking into how can I improve the whole thing. And I want to show you what I have done. This might be helpful to you. And if you have questions in the chat, let me know. I'm going to help you. If you have questions regarding data engineering in general, let me know. And then I'm going to show you, let's start with what was actually the problem last time. And just as a quick recap, is someone here who already used that, who looked into that last time? Let me know in the chat if you've seen me last week when I talked about this. Otherwise, we're going to also fire this up. So the thing is, last time I was showing you this here. And this is the project that I have built, right? That I have set up for my academy students, where we are creating a RAG system with Elasticsearch and Streamlit as the user interface, where we then can ask questions regarding our data. All right? And now with that, there was one problem. And one problem I had was the data looked good, but the return from Elasticsearch when I was writing queries was always feeling kind of random. And I created a screenshot for you here. And this is the screenshot for me last time. And this actually this shows you what the problem was for me. I asked the question in the Streamlit chat, and this returned me then chunks. Yes, it gave me I don't even, yeah, this gave me the right answer. But when I looked at the chunk, the first chunk with a 1.0 score here, that was the chunk where it says like, this is a perfect match. This was absolutely had nothing to do with the question I asked. And multiple times it was the same thing. I asked the question, but it was completely like, it was not right. It always felt like, okay, I'm getting a good answer by luck because I don't have that many documents in my store. I can show you in here, because I only have 33 documents in my store. Right? Because for every person here that has 1, 2, 3, 4, 5, 6, sometimes a bit more, 1, 2, 3, 4, 5, 6, 7, 8, 9 documents. But the amount of documents is limited, right? And that is one of my problems. And I looked into that and what can I do? What are ways to improve this? And I'm going to show you this, what I have done. Before we're going to get into that more, again, use the chat. Let me know in the chat what you think. And also if you can hear me and so on, so I know that everything works. All right, so that was the problem. And then I was exploring, okay, what am I doing wrong? And one of the things that I am doing wrong, and by the way, bring this up. I started putting this into a document for my students with the steps that I undertook to actually make this better. And we're going to talk about this in a second as well. So what have I done? First, when I look at my process, how I set this up, I made a mistake here. Because what I have done is, when I was creating the embeddings here, I was actually using Olama and my Mistral model. And that is the wrong thing for creating the embeddings. that is not good. I need to have something like a sentence transformer to actually create the embeddings, because it kind of works if you create the embeddings with Mistral and also Llama Index. It does it, but you need a good algorithm here to actually do this. That is one of the things where I actually needed to improve a lot. Right? So that, and as well on the other side, of course, then I needed to have a good embedding for my questions. And I used Hugging Face for this. Hugging Face is actually quite nice. Hugging Face is a library that you can run through Python, where you actually then use these. Basically, you can download these models. They have datasets here, but they also have a bunch of models, and I'm using here one of their models. I can show you in the code as well. Let me show you in the code what I have done. Zaebe is asking, was it a chunking issue or model issue? It wasn't a chunking issue. I was first thinking about a chunking issue because when I was looking into how I chunk this, I was in my code for my app. In here, I was doing a chunk size of 200 with an overlap of 50. And I thought, oh, maybe that is the problem here. But that is not it. I could have changed this, but I wanted to keep smaller chunks, right? So it was actually the problem that over here when I was... Where did I do this? One sec. Here, when I had my ingestion pipeline created through Llama Index, I actually used here Ollama as the embedding model, and I've done this here with Hugging Face now, and I used here this BAAI model with the normalization, but we're going to get to that in a sec. So that was the big change here, right? Because now with that, it actually creates me the good chunks and also good vectors or good embeddings for this. So let me quickly answer Aman's question. Yeah, Aman, I have that in my YouTube library. You can just go to my YouTube channel, Andreas Kretz, and let me quickly get it up again. One sec. Here. My YouTube channel, Andreas Kretz, and there you can find and there you can find the one from last time. So that was one of the things, actually fixing the embedding, because the embedding was wrong. And of course, then the same thing for my other side, right? For the querying here. As I said, this was also the problem because I used Ollama for trying to create the embedding for the question. This kind of works, and that is quite funny, I think. This kind of works, but this wasn't the right thing, right? So I went into my Streamlit app, and in my Streamlit app as well, I created, where's my sentence transformer? That's the reranker. Here, I created my embedding model, and I used, again, Hugging Face embedding, and I used the same model. Of course, I used the same model, right? So that was the first thing I've done. That was the first problem. But the problem with that was I did that, and I put this in here in my document. The outcome that I had was, it felt less random, but the matches were still like were related, but a lot of irrelevant documents ranked very high. I always had something when I was looking at my score here. It's a lot of back and forth today. When I was looking at the scores that I get from the return, the scores were always very high. 90, 0.998, 0.997, 0.99. It was terrible. So then I was thinking, okay, what can I do else? And then I got into, okay, so I had the proper embedding model, right? I was looking into how to normalize the data. Okay. So I went to Hugging Face, to the model, and then I added here normalization true, which normalizes the vector length. And you can think about this is, I actually didn't copy this out. I had that in ChatGPT earlier. The idea with that is you have your vectors, right? And these vectors can be very, very long, and others can be very, very short, which can be a problem. And some models here do this automatically. I would not have needed to do this. Some models do this automatically, and some you have to basically enable normalization. That's why I went into my code and where is my normalization here? Oh, that's the wrong thing. Here, I added here normalization is true. Right? With that, I normalize the vectors so they are always from 0 to 1. Otherwise, you sometimes have, as that, you can have a lot longer vectors, and that can actually skew the whole thing. I copied here out why this makes sense, because not all embedding models return normalized vectors. Not all vector stores use cosine internally. That's one thing. And also with cosine, it can happen that this influences a bit the returns. And we're going to talk about Euclidean distance here in a second. So I did that. I entered the normalization, but the outcome here still was the same thing. Did not really create a separation between the relevant and the irrelevant chunks. I always got so, like, it was always 99 point something. Yeah, like the user, why is that a problem that some vectors are much longer than others? It shouldn't be if you use cosine similarity, but if you use something else like dot product or the Euclidean, that is a problem. Now, I also read, and I asked ChatGPT a lot about this. ChatGPT also said it can be a problem with cosine similarity as well. I'm not 100% sure. So I just wanted to make sure, okay, I have that fixed. So I fixed that one, right? I normalized the embedding. So I went in, I used the proper embedding model. I started to normalize the data. Didn't really help. So the next thing was, and you already see this here, some databases don't use cosine similarity. Like, and I added Elasticsearch here, like Fias, they say, ChatGPT also said Milvus and Pinecone, they use dot product and not cosine similarity. So, and for that to work, you need the normalization. Right? Now, what I've done is then I changed actually my Elasticsearch to use cosine similarity, because the problem is with that Euclidean distance that this calculates the distance here, right? If you think in a 2D vector space, and you have your very long vector, or you have a longer vector, you have a shorter vector, and it then basically tries to find the distance here. And that's not what we want. We want cosine similarity, right? We want to have this here. We want to have the angle, because then, first of all, the length doesn't is completely irrelevant, and also that is the better way. So, as I understand it, and I'm not the super math genius, I'm an engineer, right? So I'm trying to find here the better solution. Now, for that, what have I done? I went into my code again, and in here, I actually went into when I create my index, and I created my index here, type dense vector, dimensions 768. I I was asking myself if this could actually be better if I have a larger vector, but it seems like not a larger vector doesn't necessarily return the better results. Right? So that, and I enabled here cosine similarity. And I had that fixed. Right? So now with that, what did that bring me? And I wrote this down. With fixing this, whoa, that's the wrong window. One sec. With that, theoretically, I have now a proper aligned embedding, right? And however, like this says here, however, the top results were still very close together. Cosine made retrieval correct, not discriminative, right? So now I knew, okay, everything works. Everything from a standpoint is correct, but I still like, where's the cutoff? Because usually what you do is, and I can show you in this, when I return the data here, I made it so this will return me 15 documents. Right? This will return me 15 documents. And then you have the 15 documents. They are still the best ones are still on the top, but they're still super close together. That was here the case with my problem. And that I actually researched is a thing that you can do with the reranker. And the reranker, that was a super, super simple implementation, but that made a lot of sense. Now, what does a reranker do? And I prepared this for you. And like, these are things, I find this super, super interesting. Let me know in the chat if you find this interesting. As it says, isn't the scale dot product better? I don't know, maybe. But I went with that. So here, with a reranker, basically the idea is the reranker, you have a model here as well. And that you give your answer or your question and the answer, and it basically tries to find out if that answer is actually relevant. Right? If you have like it says here, a contextual fit. And that actually had a really, really large influence on my returns. With that reranker, you're moving away from either this is a 0 similarity up to a 1 similarity. You're moving more towards, you have everything under -6 is unrelated, 1 to 5 is weak, around 1 is somewhat related, and 7+ is like a really, really good answer. But that is actually something that really, really worked well. Now, the only thing, and I find this very interesting, how easy this is to set up. The only thing I needed to do is add here in my query, right, in my Streamlit app, I added the reranker here as a sentence transformer, cross-encoder, with that gives me the top 5 results. So this, instead of 15, it re-ranks them and gives me the top 5 that actually from the context fit to my question. And then I added it here to my query engine. And that's all that I needed to do. Super straightforward. And that really has a big difference. So let me show you. Because I have that thing running here. Now, where's the right window? Here's my app, and I prepared a few questions, and we can see the results here. Queries. Let me copy this over here to the different window. So if we, for instance, ask here, should I make this bigger? Like this. So let's enter debug mode that we see the documents and the results. Come on. Then we ask, who frequently reminded Captain Kirk of system limitations? Right? And then we send this. So wait a sec. I don't know, sometimes it's very, very fast, and then other times it takes a second. Here. So it says rightly, Montgomery Scott frequently reminded Captain Kirk of system limitations, right? And then when you look at the scores now, here, this score is a 6 score. So when we remember here, 6 is almost the direct answer, it would say. 6 score, and in this frequently reminded Captain Kirk of system limitations. Right? So that is directly in here. Now when you look at the next chunk, that is already a -10. And that is really good. So these are basically irrelevant. It re-ranked them as irrelevant. And this way you can have a really nice, like if you have a really nice user interface, you could say the cutoff is -6 or something, and then you just don't give it these scores. You know what I mean? Let's ask a different question. What else could we ask? I had here, who worked with Dyson spheres before? Because Scotty also has that in his CV. So let's ask this. Okay, we already had that. Montgomery Scott worked with the Dyson sphere in the context provided. Let's look at the context. That it always scrolls down. Here, the first one. As you can see, it's not perfect. It has a -1, but it has Dyson sphere in here, right? And then here, the last one is -11, or the next one is -11, Jeffrey Lebowski. That doesn't make sense. So this, from a ranking perspective, is really, really good. Mosin, where can I ask the previous, access the previous session here? Just go to my YouTube channel, and there you have, like, let's see. Here, go to my YouTube channel, and then go to live. And here's this one. Here is the last one from 5 days ago. Yeah, so that finally works, and it works really, really well. Like, also when you ask something that isn't super direct, like who has Starship experience, and I have Cara Thrace, like Starbucks from Battlestar Galactica with the CV, and also Scotty. So they too should come back, right? So let's see what this returns. Already have the chunks. Retrieve chunks. The first one, I think that was some cold start issue from Olama, I'm guessing. Scotty and Cara Thrace both have Starship background, as they served on various Federation starships in their career. As you can see, it's not perfect. We have a -6 score here for this. Multiple Federation starships, so it's kinda difficult. -8. It's not 100%, but it kinda gives us a good answer. And I find this really, really interesting. I had another one here. Who can do advanced cluster management under fire? And I don't even remember for whom that was. That was also for Scotty. That has a 2.9, and the next one -10, right? So works really, really well. Cluster management under fire here. Remember, do we have here cluster management under fire? I mean, is this awesome or what? I think that is super cool. And those were the 4 things that I've done. And we had that question with the dot product. I need to look into this if this is better, but these are the 4 steps. I added the cross encoder was really, really good for then later, after I retrieved the documents, for ranking these. but then you already have the document. So if the documents that you get are not good, doesn't make sense. But because I went here and I first got a proper, oh, I'm not showing it, but because I went here and I got a first proper embedding model, that then solved a lot of things. That solved that. I did the normalization, which most likely also helped because this was running the Euclidean distance Elasticsearch. And then I switched that to cosine similarity, which didn't really make a change. And then I added the cross reranker. So this first step already gave me good results, but they were close together and I was trying to get them further spread apart, right? Yeah, Robert, exactly. That is one of the things. The elegant ways to improve this is to add some metadata that clarifies names, vessel, and starships. And that is, in this, what I've shown you today is, this is just the semantic search feature, right? And I added that here by filter by person, because if we look at that, this has the metadata, because what I've done is, in my document, before I put the data in, I actually extracted only the name here as the metadata. So I can actually use the metadata and I can also write queries on top of the metadata. But that is, of course, a combination of both is most likely the best. Can I find something in the metadata? And if you find something in the metadata, then it's fine. If you don't find something in the metadata, then switch to semantic search, or the other way around, right? So that is, that's really, really cool. And I want to share this with you because this took me a while to figure out. And I basically sat there the whole Monday figuring out, okay, what could I do? And of course I was using, I'm an engineer, I'm not the mathematical genius. I'm asking ChatGPT, give me tips on what can I do, because I'm also getting into these topics. And that's why I love creating these kinds of courses for my Data Engineering Academy, right? Because this allows me to get into these topics as well. It's not perfect, and I have to admit that I'm also doing stuff wrong, and I've done some stuff wrong. So it's getting better. Asad says, I think I was just missing the re-ranking step. Yeah, the re-ranking, the only thing that the re-ranking does here, again, let me show you in the code. The re-ranking is you add to your query engine that I created through Llama Index. Where's the, here, query engine. And that has here, that's the Llama Index core query engine. And what you do is, you say, okay, what's my response mode? I want to have compact responses. And which LLM am I using? I'm using Ollama for this. And then you say, okay, I want to add a reranker as the post processor here. And the reranker is just, am I showing it? Oh man. No, I'm not showing it. Sorry. I lost track. Where was I? So again, let me quickly do this again. So in here, I created here the query engine, right? Or index as query engine. And in that query engine that I create here with my index, here, retriever index as retriever, index vector store from ES vector store, that's my Elasticsearch vector store. In that I query, and I add here this reranker as the post processor. And all that does is it takes the question I ask and takes the 15 documents that it returns, or that Elasticsearch returned, and tries to figure out, is that context actually fitting? And the reranker is super simple. You create that here, sentence transformer re-rank, and then you just use a cross encoder. And that then narrows it down to 5 documents, and then you get these 5. now we don't see them again because I clicked away. You see these 5 documents. So nice, absolutely. I love this. And I need to quickly record a video, or maybe I cut this down here from what we've done here to actually give this to students. I didn't have debug mode on. Yeah, there's a longer question here. Would you advise us, would you advise use this to build a self-service tool for sales teams so that they can pull insights from the data warehouse, e.g. what was the churn rate of the previous month, or how many unique members bought this product last year? I mean, it always depends on what you do, right? When you look at the whole pipeline here, now in this we have Elasticsearch, right? And your LLM, the Mistral LLM, then just prepares the data, right? So you could try to translate the queries that people run into SQL queries and then query that from your data warehouse and then prepare that with Mistral and give good results back. But this basically works, I would say works best for you have text. When you have documents and you're embedding these documents or texts so that you can run a semantic search and find these documents again. So for that, I think it's not that simple. Like how do you pull insights from the data warehouse? Like what's the churn rate? How do you query what's the churn rate, right? How many unique members bought this product? How does it actually query the data from the store? That is always the difficult part or the important part. And so it's not that you somehow bolt an LLM in front of it and it returns you good results. You somehow need to like find the right data first. And that was basically my problem here as well. My biggest problem in the beginning, before I fixed all these things, that it was that my embedding model, because I'm an idiot and I used, instead of using a Hugging Face embedding model that is actually made for embeddings, I used that Olama Mistral, basically a Mistral LLM to create the embeddings, which is like, now that when I found this, it's like, okay, that doesn't make sense. Right. Yeah. Anything else? Ask me a few questions. Come on. What's on your mind, guys? I have a few more minutes. 30 minutes here for this. What are you working on? What questions regarding data engineering do you have? If you want to find all this, not LinkedIn. You can go to learndataengineering.com. I have my academy and my coaching program there, and in the academy now we have an AI engineering track. And in there, this is here, the create a private retrieval augmented generation chatbot using Elasticsearch and Olama. Actually, that still, it says coming soon. That's actually already here. That's this project here. And we already have something on semantic search with a simple, okay, I'm indexing log messages. And then next comes here something with the chatbot, where I already developed this. So this is 90% done, where you ask in Slack, basically the bot channel, the AI channel, and that gives you answers. If I'm running all these on my computer, yeah. What I'm doing is I have Olama installed here, and you can either ask Olama through here. Oh, yeah, let me see. Let me show you. Here. So you can have basically a chat, just like with ChatGPT. Let me make this bigger. Can I make this bigger for you? No, I can't make this bigger. I can. Hi, are you running 100% locally? Let me see what it answers. Oh no! Don't download the model. I had the wrong model here. So you can select the model here that you want, and I only have Mistral installed here. And this way you can very quickly download the models and run your own models. Right? And come on. As I said, this has some sort of a cold start always. Because, yes, this is... bullshit. But this is downloading the... you download the model that you want, and you can have a lot here. DeepSeek, Gwen, Mistral, and a lot more as well. And the cool thing is this offers an API. So when you have your code and you want to run this, you can just use here the Ollama host and the model, and I have that in my Docker Compose. Where did I have that? Ollama model Mistral, and here's my Ollama model that goes basically, because I'm using a Dockerized environment, that goes onto the port 11.40.3.4, and that's a cool thing. I really like this. And this can give you answers, and with a RAG application, this can also give you answers on your local data. And this is usually fast. What is data? Data engineering. Look. So this is super fast. Can RAG help create SQL queries? Is an agentic AI better in creating SQL queries from questions? Absolutely. These things make no sense. A RAG system doesn't create you these. A agentic AI doesn't create you this, because behind an agentic AI is the same thing. And let me show you this again here. Behind every system basically runs an LLM. And what creates you the LLM? Or what does the LLM? The LLM gets your query and creates you the output. So that will create you the SQL code, right? You will ask, and that will create you the SQL code. The agent is just sitting in front of this. Do I actually have this? Let me quickly open this up. I have that for the next course. Let me show you. One sec. Here. Basically, if you have an agent, and let's say this is a Slack agent, right? The agent needs to needs to do something. And either you say, okay, I'm writing in Slack a message, and that goes directly into my agent is listening to the Slack and then forwards it to the LLM to get the information. Or the agent would then send to the MCP server the query, and that would then return get the data from your vector store, get it to the LLM. LLM will return you the result, or create the result, the answer, and then send that to the MCP server, and the MCP server will then forward to the agent, and the agent will give you the answer, right? So that is the thing here. The LLM is going to create you your SQL code. And that's how the agents work. The agent itself, the agent alone is dumb. And do I have the code here for the agent? Let me show you. Let me see. I can also look at this in another window here. Let me see if I have here a... One sec. I'm logged in with the wrong user. I don't have it right now. Maybe I can talk about this next time. Yeah. But that is... So an agent is not better at creating SQL queries, because what is creating you the SQL query? The LLM. And the better the LLM, the better the queries are going to be. All right. Yeah. Maybe I can... No, I can't get that to you. I'm not sure why I don't see all the comments here. Because there's a question on LinkedIn that says what GPU I'm running. I can show you. I'm running a good GPU, of course. Where do I actually see this again? Here. In this machine, I'm running a NVIDIA Titan RTX machine. So it's a few year old, the graphics card. But it's not like this uses a lot of memory or a lot of resources. Like let's ask a question. Let me see. Now again, we have some cold start here. It's not crazy, right? It's just a blip here. Did we even see something in the memory? Maybe a bit in the memory usage, but not a lot. Utilization, 8 gigabytes of memory used, 18% utilization. Tell me, let's compare this to data science. Show me a comparison to data science. Let's see. So it's 30% or 20% utilization. GPU memory doesn't really change. Yeah. All right. So and I think I don't even know where the Titan RTX nowadays is, but I think with the newer graphics card, they are even more powerful, right? So, yeah. Of course, you see my whole memory here is 16 gigabytes on this machine. And it's basically full because of all the Docker containers that I'm running. Here, that's basically my Docker setup, right? We have here the rack, we have Kibana, Elasticsearch, we have Fast API running, we have Streamlit running. That's why I have such a high memory usage. All right, let's finish here. Thank you very much for being here. If you have questions, let me know again in the chat. I'm going to go off screen here, but I'm staying here a few minutes. So if you have questions, put them in. And otherwise, again, if you want to learn data engineering, best place here, learndataengineering.com with my huge academy, over 30 courses, coaching, and basically I have everything here. From platform pipeline design, security, API fundamentals, Airflow, Spark, Databricks, Kafka, MongoDB, Elasticsearch, Snowflake, dbt, Iceberg stuff. Then full end-to-end projects with AWS, Azure, GCP. The modern data warehousing with also basically data lakes, machine learning, semantic search, RAG, and so on and so on. Dockerized ETL. A lot of stuff, right? Docker fundamentals, and so on. Data modeling, of course. And with that, see you next time. Thanks for being here.